Excellent. Okay, so thank you very much for joining this session about how to verify for security early and often. So in many organizations, the testing for security usually is done as a scan, then fix approach. Security teams runs a scanning tool, conducts some pen tests that triages the results, and then presents the development team with a long list of vulnerabilities. This is usually referred to as the hamster wheel of pain. The question is, can we do something else better? And this is what we will explore as part of this presentation. Where we will start the discussion by talking about quality. And one of the companies that is best known for its quality produce is Toyota. Total quality control in Toyota is achieved using two principles. The quality is built at every stage, and the quality is continually improved. To achieve this total quality control, each and every member that works within the company must ensure that only the best work is then passed on to the next process. No defects, no matter how small they are allowed to move down the manufacturing line. So rather than having the inspection at the end of the manufacturing line, Toyota relies on each individual to be an inspector to ensure only the best quality products is passed further down onto the production line. Each member is responsible for the quality of his own work and aims never to pass poor quality to the next stage in the process. If anything unusual is noticed, then the member can trigger an alert by pulling the Andon Cord. And this is a cord which runs alongside the production line for the whole length. This stops the production line, allows time to investigate before continuing. When this is pulled, then a team leader will personally go and see the issue at the respective station and thank the operator for stopping a defect from going down the manufacturing line. And that's the magic ingredient. Any Toyota employer is fully empowered and actually expected to pull the Andon Cord every time they see or are aware of a defect. When first discovered by Western manufacturing companies, the Andon Cord approach was horrifying. How can you let anyone on the factory floor to stop a multi-million dollars production line? This was the kind of freedom the Western senior executives were not used to give away. And this was the mechanism that actually empowered everyone within the company to stop defects and then fix them before reaching the customers. And this proven success story has then later been taken over by the company. Probably the most noticeable is the Amazon. A little bit about myself. My name is Katy Anton, and I come from a software development background. I'm also a OWASP leader, running a couple of OWASP projects in the chapter, and I currently work as application security consultant at Veracode. And this is where I work with development teams, architects, and help them to correctly remediate the security vulnerabilities that have been identified by various tools. So the software development cycle consists of some basic cycles are the requirements. For the simplicity of this presentation, I'll just consider the requirements and design in the same thing. There are more things that can be added at the design stage, but not within this presentation. Then once the requirements have been identified, then we have to implement the specific piece of functionality, coding. Then we have testing to verify that the code is doing what it's supposed to do, and then deployment when the software is packaged and deployed in production. Great, so let's start with the requirements, because one of the problems is how can you think of security requirements? It might be a little bit tricky, especially for non-security people. Thankfully, there is an ASP project for this, which is great to use it as a for guidance. And this is the OWASP Application Security Verification Standard, or for short, ASVS. It's a comprehensive project. It has 14 categories of security verification requirements, split on 3 levels. And let's say that, for example, someone wants to implement new functionality or refactoring. So, for example, authentication, and this is one of the requirements from the latest version of the ASVS. We should verify the application generates a new session token on user authentication. To consider this requirement into the software development, what we can do is to use user stories. The user story focuses on the perspective of the end user and describes the functionality based on what a user wants the system to do for them. For this, we can use use cases, and this is a way to actually say, as a user, I want to do X, Y, and Z in order to achieve a goal. This is one way, but we can also use this particular one to think from attacker's point of view. And that's where we can put our black hat on. In this case, they are called misuse cases, abuse or misuse cases. And this is what we can think of as an attacker. I want my system to not be able to do X, Y, and Z in order to compromise, steal information, disable any key function. Moving back to our requirements, so this would translate, the initial requirement that we picked will translate into a use case and then an abuse case. And both of them can be then used to be converted in the respective unit tests and functional tests. So let's say that we have identified now the requirements and we are moving into the development. This is the part where a developer will start implementing the required code changes into the so-called feature branch. This is kind of a standard into the software development cycle. At this stage, when the developer works in its own code, what he can use or she can use is to ensure that, first of all, the software will have those requirements that we have identified at the requirement stage, and to implement any unit test that can be derived from that security requirement. Also, this is a great place to actually have some secure coding and use for the development secure coding. Some great OWASP, a great OWASP project is the OWASP cheat sheet series. What this helps is gives you specific guidance for a wide range of languages and the wide range of security vulnerabilities. And also, at this stage, when writing the code, another tool that you can use is to use an IDE security plugin to actually help scan that code that has been developed for that particular functionality. So that's another way to test for security, to verify for security, while you are still in your IDE. From the comfort of your IDE, there is IntelliJ, Eclipse, Visual Studio, whatever fancy IDE you want. So at requirement, after the code has been done, it comes the point when this new development is merged into the code. This is another good point for security verification, and for this can be used box standard peer code review. If it is implemented where the team is trained to take into account various security standards, various security coding basics, this is a good way as well to share the security knowledge within the team, and another point to verify for security. So we can start from the requirement, and this is where we can use the OWASP ASVS to identify the security requirements for the piece of software functionality we want to develop, refactor. There, during the coding, the implementation, we can start identifying the unit test from the ASVS requirement, apply secure coding, and have as a guidance the OWASP cheat sheets, and verify for security using a ID plugin to help you test your code in the comfort of your own ID. And again, have the peer review as an extra point of checking for security. Once the code now has been into the main development branch or master, we can actually trigger at this point test, and the first that can be used are the functional tests which have been derived from the ASVS requirements, but also can trigger, for example, a source code analysis, a SAST, to verify for the security of the entire code. And when we deploy, we prepare the code to be deployed in production. This is the point where you now are creating your release candidate branch, and then this is when you start testing of what is the code that will actually go in production. And at this point, you can have the entire suite of functional tests, including the ASVS ones that have been derived, SAST, DAST, but these are not the only one. And you can actually have other tools. You can automate some of these. You can also have penetration testing if that will suit your cycle, although the penetration tests are manual. So there are more that can be done at this stage, but this is just a suggestion. Great, so hopefully in this very short presentation, I have given you an understanding of the points and high level of what to use at each of the stages of the software development cycle in order to verify for security from the beginning, from the requirements. Place alerts, they can be in CI/CD pipeline, but also can be humans, like during the peer code review.